Hi everyone, my name is David Klee, founder of Sequilibrium. Welcome to Module 6 of my course, the SQL Server on VMware Accelerator. We just wrapped up a good overview of the hypervisor itself. What happens when you take a lot of these ESXi hosts and group them together? This module is designed to help show you certain properties that we can manage with a cluster of VMware hosts to make SQL Server even more highly available. In this module, we're going to cover the importance of the vCenter appliance, discuss what makes up a host cluster, and then talk about some of the high availability features that come along with the host cluster that can complement and sometimes replace our SQL Server high availability solution. We're going to talk about host-level VM load balancing with the distributed resource scheduler, and then ways you can boost your availability and performance with Affinity Rules and resource pools. So far, we spent a lot of time talking about the individual host itself, but there's a lot more to it than just a single host. The VMware hierarchy is a little interesting in its architecture. At the very top of the stack is the vCenter server. The vCenter server is the master controller and orchestrator that understands everything that's going on in your virtual environment. In the hierarchy underneath the vCenter server comes the defined data center. It's more of a logical construct so that you know the physical location where these servers are located at. It helps you group the cluster logical locations. Each data center can have one or more VMware host clusters. A host cluster is a group of physical hypervisor hosts that are logically grouped together and governed by the same set of availability and controlling rules. Usually, the storage in your environment is owned and restricted per host cluster. This is so that every host in a cluster can run any of the virtual machines in the cluster, but they're isolated for security from the other host clusters. In smaller environments, you may just have a single data center and a single host cluster, and maybe in even smaller environments, you may not even have a vCenter appliance. It might just be a few standalone hosts not configured in a cluster and operating independently. Any of these configurations are fine as long as you know what you're doing. As the environments get larger, I see purpose-built clusters for a given purpose, multiple clusters in each of multiple data centers, and potentially multiple vCenter servers to better scale out by design. These environments can be quite large. I've seen some environments that have thousands of hosts and tens of thousands of virtual machines. I've seen other environments that have a single host with 2 or 3 virtual machines, and that's all they need. No matter the scale, when it comes to SQL Server, there are very common things for all of these that we can address and improve both the performance and the availability of our critical servers. At the highest level is our vCenter server. Like I said before, it's the master controller and the system that collects and stores all of the performance statistics from each of the hosts. You need to request read-only access to the server for the SQL Server VMs and the hosts that they reside on. As we go through the rest of this course, you're going to learn about many performance KPIs and metrics that need your visibility here. The vCenter performance statistics retention levels are set to, in my opinion, an inadequate level by default. If you take a look at the interval duration, you'll notice that they're grouped in 5 minutes, 30 minutes, 2 hours, and 1 day intervals. These are retained respectively for 1 day, 1 week, 1 month, and 1 year. By default, the default statistics collection level is set to 1 for each of these intervals. A default value of 1 is the lowest setting possible, and not all of the important metrics are ever collected beyond a real-time view, which is only held for 1 hour. For some of the other intervals, the data is stored as an average of an average, or sometimes added over all the samples of the rollup interval. What this really means is that with the default values, you only have a rolling 1 hour of decent information at your disposal if you're troubleshooting an immediate performance problem. After that hour, only a small amount is stored into the Postgres database inside the vCenter server appliance, and the amount stored is usually not granular enough to actually help your performance troubleshooting. At the 1 day point, your granularity is reduced further as the data is rolled up again. After 1 week, the data is rolled up again, and you lose even more granularity. I highly recommend that you work with your VMware administrators to change from these default statistics levels to values that make more sense for better coverage and longer retention of the metrics that we need to help performance troubleshoot. Highlighted on the screen are my recommended statistics level for each interval duration. If you go from top to bottom, it's level 4, 4, 3, and 2 respectively. The only thing to watch out for here is that the partition that the Postgres database resides on the vCenter server has enough free space to store the extra information. The vCenter General Settings page has a calculator at the bottom of the page that can help you determine the amount of space required. Your VMware administrator can then SSH into the vCenter appliance and confirm if enough space exists, and expand the partition with a little help from the VMware knowledge base. Your VMware administrators might also be using advanced collection tools that are separate from the vCenter server, such as vRealize Operations Manager or VM1. These tools will collect and store much more granular data on an ongoing basis. If this is the case, you need to demand that you get read-only access to this data, and they need to work with you to show you where this data is at, as these tools are not the easiest to mine for information. They can certainly grant you read-only access rather easily into any of these tools. If they do grant you access into these tools, you may not need to change the vCenter statistics levels. Confirm that you have enough information before you make this call. Make sure to work through the performance tuning module for all of the specific counters that you will need to know and to find in the other performance monitoring tool before you can call it good. Now let's tackle the host cluster. Like I mentioned before, the host cluster is a collection of all of the hosts that are governed by the same set of availability rules. Hopefully, all of the storage is presented to all of the hosts in a cluster. This allows any host in the cluster to actively connect to the same shared storage and successfully run any of the virtual machines in the cluster. You can see here an example of two hosts clusters. One is a 3-host cluster, and the other is a cluster of just one host that is placed into a DMZ for a few public-facing servers. vCenter is still controlling and governing everything, and we can centrally manage everything from this one spot. If vMotion is properly configured, any of these servers can be moved while running from one host to another in the same cluster. vMotion is a term that VMware uses to relocate VMs while operational. The storage stays on the same data store and the underlying compute node changes. The actual technical process of this is fascinating. Once the command to move the VMs is received, the source host starts copying the contents of the virtual machine memory to the destination host. Once the first pass is done, it goes back and copies what has changed, and so forth until the memory change delta is 0. Once this happens, it swings the network pointer for the virtual machine to the destination host, and the CPU becomes active at the destination, and the virtual machine is now successfully moved. During this process, your servers will usually lose 1 TCP ping. Ordinary application servers will treat this as a packet retry operation, and in all but the most sensitive applications, this vMotion operation is seamless to the application and the end users. Okay, we're going to move this jump box from one host to another. If you notice, we're on host number 3 here. So if we right-click, migrate, we're going to change the compute resource only, and we're going to go to host number 2. Compatibility checks are good. Network adapter and assignment stay the same. We're going to schedule this with high priority so it runs right now. Go. Now it's moving the contents of memory from the 3rd host to the 2nd, and we're done. That's it. How cool is that? We're now up and running on the 2nd host. It's as simple as that. That is a vMotion, and that's fantastic. The very first time that I saw this work back in 2004, I was absolutely amazed, and it still feels like watching magic work. The biggest challenge is that during the time span at which the memory contents are moving, you might encounter a small to moderate performance penalty on the virtual machine. If you have a high rate of memory change, the hypervisor might perform an operation called stun, where the virtual machine itself is told to slow down so that the rate of memory change is decreased and the transfer rate can keep up. Most of the time, this is really not that big of a deal and barely even noticeable. However, if you have a really large memory footprint or your rate of memory change is quite high, this can drag on. What we need to do is perform some checks to make sure that our vMotion time is kept to a minimum. I've got a trick that I'll show you to improve the speed of vMotions with the hardware you have today. I mentioned this back in the previous module around multi-NIC vMotion. A number of cluster configuration settings exist to improve the availability and the resiliency of this platform underneath your critical SQL servers. High availability, or HA, is pretty ubiquitous. Load balancing through a feature called the Distributed Resource Scheduler, or DRS, is a little more tentative. There's also a CPU-specific feature called Enhanced vMotion Compatibility, or EVC, that we can leverage to mix equipment generations and still keep things flexible. And lastly, there are rules that you can enforce to keep machines close together or separate them to enforce your SQL Server high availability solution. The very first thing to check with your VM administrators is that vSphere HA is enabled. vSphere HA is a reactive setting that will power on virtual machines that go down if a host fails for any reason onto one of the remaining hosts in the cluster, if enough spare compute resources exist to successfully power on the virtual machine. Essentially, if a host fails for something like a mainboard crashing or something pretty serious, but it's just localized to a host, the vCenter server will detect the outage, It knows what virtual machines were on that host at the time that it went down. Because our storage is accessible amongst all hosts, it can restart the downed virtual machines onto some of the remaining hosts. Your virtual machines will experience an outage, but in most circumstances will be back up and running within about 2 minutes and 45 seconds, give or take. I'm okay with this most of the time, even if your SQL servers are in a highly available configuration already. Think about it this way. If you have 2 nodes in a SQL Server failover cluster instance that are on physical servers, and one node goes down because of a hardware failure, your availability solution is at risk until that node can be repaired by your IT department or hardware vendor. Please note that when your hardware vendor says a 4-hour SLA, that usually means they'll call you back within 4 hours, not usually that it's going to be fixed within 4 hours. Your SQL Server availability solution is at risk until another member can be added to that availability solution. With VMware HA, the resiliency in the platform greatly reduces your window of risk, and your SQL Server HA solution will be back up momentarily after a failure. This is the host failure response in the cluster settings pane. The setting is almost always enabled, so it's usually not a big deal, but if they've not enabled this, ask the VM administrators why not. There are other options in here for more advanced outage scenarios, such as what happens if the host management interface goes unresponsive or if a virtual machine were to blue screen. It's less likely to see these scenarios, so most VM admins will just not bother to configure any of these settings. I usually find that to be just fine. There are a few settings in here that some VM admins may not know about. The most engineering term that I've ever heard is under the Admission Control tab. It's called Host Failures Cluster Tolerates. Say that 3 times fast. Essentially, this setting is how you determine how many spare resources to reserve in your host cluster in case a host were to fail. The screenshot on the screen ensures that one host's worth of CPU and memory resources are kept in reserve on all the hosts combined in the cluster. There are some advanced scenarios where instead of cluster resource percentage, you can specify a certain amount of memory or CPU gigahertz to be left over, but most of the time, we care more to simply say how many hosts we want to remove from the cluster and maintain capacity in the case of failures. Now, sometimes a VM administrator will disable the settings so that they can run the cluster a little more warm. This means you may not have enough spare resources to power on all of your virtual machines in the event of a host failure. Sometimes this is acceptable, sometimes it is not. There's an option in here to set a priority on restart so that your most critical VMs will come back. I prefer to set this as Host Failures Cluster Tolerates and enforce the limits so that I just don't have to worry if some VMs are not able to be powered on. Make sure to work with your virtual machine administrators on something called N+X host capacity. You want to make sure that you have enough spare resources available to keep everything running if you have to bring 1 or more hosts down. I like to enable the setting to make sure that we have the Host Failure Cluster Tolerates setting to a rather conservative value. Hosts can come down for planned operations, such as upgrades or updates, and you don't want to be caught off guard if either run degraded or have to turn VMs off. There's another feature called the Distributed Resource Scheduler, or DRS. Think of this as host-level load balancing amongst the virtual machines in the cluster. If a host machine suddenly gets much more active, it may start to impact the performance of some of the other VMs on that same host. DRS can automatically vMotion some or all of the other virtual machines on the host to remaining hosts to maintain performance. There's a migration threshold slider from conservative to aggressive that defines how aggressively DRS will kick in and vMotion VMs around. It's up to your organization's prerogative on where they want to set this value. Most of the time I find that the value in the middle is sufficient for most SQL Server workloads. It doesn't move anything around until performance starts to get impacted, and then it'll only move around what it needs to regain it. Sometimes people don't want things moving around until it's absolutely critical, and then you can move the slider towards conservative. Other environments are quite aggressive, and as long as our applications can accommodate the vMotions without disruption, I really don't have a problem with this for most workloads. If the automation level is set to manual, it can alert on an imbalanced load, and then the action can be performed manually. I prefer to set this to fully automated, as I just don't want to take the time to micromanage these things. There's another setting under DRS called Predictive DRS. If this setting is enabled, then vRealize Operations Manager is a prerequisite for enabling this feature, and it will use its telemetry to understand the resource consumption patterns of the virtual machines in the cluster. If it finds that a virtual machine becomes much more active at certain periods during each day, it can respond proactively by vMotioning things around ahead of when the VM gets busy. It's essentially doing the job of the load balancer ahead of when things can become a problem to help maintain performance. It does require that your organization have purchased vRealize Operations Manager, but it is a really nice feature to have. Underneath the additional options for DRS is a setting called Memory Metric for Load Balancing. There's a setting called the Active Memory Counter that I'll go into great detail in the Performance module with, but I'm going to touch on it here. The Active Memory Counter is a metric that VMware has used for many years as a way to estimate the active memory actually used by applications running inside the operating system to the virtual machines. The problem is that it is measuring how much memory has been read from or written to every 20 seconds. For applications such as SQL Server who do their own memory management, and especially for things like SQL Server who have a storage read cache that consumes a lot of memory, the Active Memory Counter is quite inaccurate to gauge memory usage patterns with. If anybody wants data from the vendors supporting this stance, please review the SQL Server on VMware Best Practices guide available over at vmware.com. It contains a direct statement stating that the available memory counter should not be used to gauge SQL Server memory footprints or usage patterns. I know this because I put it in there. The setting memory metric for load balancing can be enabled to load balance memory based on the consumed memory of the virtual machine rather than the active memory. For your SQL Server environments, you're hopefully not overcommitting memory on each host, so I highly recommend checking this setting so that the memory load balancing is much more accurate. Now, we have to worry about SQL Server availability just as much as we have to worry about performance. VMware HA is fantastic for restarting VMs that went down if a host fails. What happens if you're running a SQL Server high availability solution, and because nobody communicated to your VM admins that this is a highly available set of virtual machines, all members of the SQL Server HA solution accidentally make it onto the same physical machine? What happens if that host fails? This is a real scenario, and if that host fails, your SQL Server HA solution is completely down until the virtual machines are restarted automatically. This is not a situation that will make you or your organization very happy, and it is easily preventable. VMware has some fantastic rules that can be enforced at the cluster level. These are called Affinity Rules. You can enforce a separation rule where you say that virtual machine A should not reside on the same host as virtual machine B. Enforcing the separation can greatly reduce your risk of a SQL Server highly available solution going down because of a single host failure. You can also pin a virtual machine to a single host. I don't personally like to do this, but there are a lot of use cases where this is strategic, such as enforcing that your SQL servers stay on one or a few hosts in a cluster to minimize your SQL Server licensing liability. If you're running a SQL Server HA solution in a virtual environment, make sure that you work with your virtual machine administrators to inform them that these virtual machines are in a highly available configuration. It's quite trivial for them to set up a rule to separate these virtual machines amongst your available hosts in the cluster to maintain availability. The other thing with this is that we need to make sure that our failure domains are set up appropriately. Everything in your data center can become a single point of failure given a catastrophic enough incident. For example, if a two-member SQL Server failover cluster instance resides on the same blade server and that blade fails, your SQL Server HA solution is down. Anti-affinity rules can help prevent that. However, what if you're running on a blade server environment and your SQL Server HA virtual machines are not on the same blade, but in the same blade chassis? If the blade chassis were to fail or suffer an outage, your SQL Server HA solution is down again. Defining the failure domains of what could go wrong and understanding the impact of these levels of outages are very important for highly critical machines. Make sure that you understand the physical server topology in your host cluster and work to identify the risks associated with any single point of failure. It could be as simple as defining that SQL Server HA virtual machine number 1 resides on any of the hosts in a blade chassis number 1, and the highly available second member exists somewhere on the second blade chassis. Whatever you do, make sure you understand this and work with your VM administrator so they can understand your SQL Server HA configuration so you can engineer the best possible platform. VMware also has the ability to allow similar but not quite identical CPUs to coexist in the same host cluster. It's called Enhanced vCPU Compatibility, or EVC. In some environments, host hardware upgrades are more incremental, with one at a time being replaced instead of replacing an entire cluster because of budget cycles. Think of this scenario. When we turn on a virtual machine and the guest operating system sees a CPU extension inside the CPU chip itself that it wants to leverage to make something better, an hour later, DRS load balancing kicks in and moves this virtual machine to another host in the host cluster that just happens to be a little older. What if that CPU extension does not exist in the destination CPU? Usually, you get an operating system blue screen. That's absolutely horrible, and we simply can't have that. So by default, VMware does not allow you to do this unless the CPUs are 100% identical. EVC allows you to dial down the CPU instruction set to the lowest common denominator so that your presented CPU instructions are identical across the host cluster. While I normally don't like mixing host hardware, it's usually not a big deal for SQL Server performance. If your CPUs across the host cluster are pretty close, enabling EVC can help you make the most of your platform without an even higher expense when you replace everything in the cluster. Just make sure that it's set to the most recent CPU generation that covers all of the CPUs in the host cluster. A big challenge with EVC is that every VM in the host cluster must be turned off to enable it. That's usually why I recommend that if you're even remotely running a chance of mixing hardware like this in the future, you enable this from day one. You can actually set up the CPU generation equal to your current CPU generation in case there's a chance of adding newer hardware into the cluster in the future. Resource pools are a logical way to prioritize virtual machines over others in the resource hypervisor schedulers. In the event of resource scheduling pressure, virtual machines in higher priority resource pools will take precedence in the scheduling queues, and the other virtual machines will have to wait until that contention is resolved and those tasks have cleared. The way I love to engineer these is as a 3-tier resource pool. It's really straightforward and can be managed at a macro level. I call them Tier 1, Tier 2, and Tier 3. Tier 1 contains CPU and memory resource shares set to high. I prefer to not use a reservation or limit or specific share values, as if the total available resources in the clusters change, these values would need to be updated. Tier 2 contains a share value of normal, and Tier 3 contains a share value of low. Feel free to modify the suggested purposes for these tiers, but I usually start with saying that Tier 1 is reserved for business-critical production. Tier 2 is business not-so-critical production, but still production. Tier 3 would be anything pre-production. Aligning them in this manner means that your most critical servers will get top priority in the scheduling queues. The others are not held back if no scheduling pressure exists, but if any do exist, they have to wait for the tasks in Tier 1 to clear. The same goes for Tier 3 waiting for Tier 1 and Tier 2. Whatever you do, do not overuse resource pools. Some organizations use these as folders, which will only introduce greater performance penalties over time. It can actually introduce CPU scheduling problems for many of the virtual machines if too many resource pools or nested resource pools exist. If you're just trying to group similar virtual machines, please use folders instead of resource pools. That will do it for our VMware host cluster. These are fairly straightforward and are usually set up and managed by virtual machine administrators. They can grant you access to just a single cluster if your SQL servers are confined there. Let's jump to the SQL Server virtual machine to learn how to optimally provision virtual machines for your SQL servers.